best porter in that new SB2C.
Now, what do I like it? He's coming in now. Let's wait for him and find out. I want to ask him some questions anyhow.
Hi, fellas. Nothing to do?
Yeah, but we're waiting for you.
For me?
Yeah, we want to get some dope on that new Helldiver you just took up.
Okay, fire. Ask the professor anything. I'll try to answer.
Well, in that last dive you just made, you seem to be moving pretty fast. How about it?
Well, no. That engine and the air blast make a lot of noise, but I wasn't diving so fast. The dive flaps take care of that. Tell you what, if you guys really want to know, I'll show you some of the features of the plane.
Yeah, I'd like to get a checkout on it.
Okay, let's have a look. There's one being taken out to the line now. That's it, gents. The Helldiver, sometimes called the SB2C. She's a scout and a dive bomber, and can deliver depth bombs or a torpedo as well. And this baby's at home with land-based squadrons or on aircraft carriers. She's powered with a Wright Cyclone engine, delivering 1,700 brake horsepower at takeoff. Empty, it has a gross weight of 10,114 pounds. 16,607 with maximum bomb loadings, or 16,812 pounds when carrying a torpedo.
Her bomb load is carried inside the fuselage and may consist of two 500-pound general-purpose bombs or two 1,000-pound armor-piercing bombs.
Or a single bomb which may weigh up to 1,600 pounds. And with bomb doors removed, a 2,000-pound torpedo may be carried on a truss structure externally. Notice the widely spaced wheels. They give good stability and directional control on the ground, and the oleos are sturdy and rugged to take the punishment of rough carrier landings. This area, which takes a beating from rough carrier landings, has been structurally reinforced with a heavier gauge skin and with strengthened internal framework.
For normal operations, a fuel capacity of 320 gallons may be carried in the 3 tanks, all of which meet requirements for all maneuvers. 110 gallons in the fuselage and 105 in each of the wings.
An auxiliary droppable bomb bay tank of 130 gallons capacity can be carried for long scouting missions. And in addition, 2 58-gallon droppable tanks can be hung from the wing bomb racks.
Boy, you can really tote a load of fuel for scouting missions. Let's see, that's 320, 130, 58 times 2 makes a total of 566 gallons.
Yeah, but you ought to see some of the other things. Here, let's watch these guys get her ready to go. The starting procedure the ground crew is about to go through has been found by tests to be the best possible for the plane. It works well in temperatures down to 30 degrees Fahrenheit without oil dilution. Below that, oil dilution is necessary. When they're about to start the engine, signals are exchanged to be sure that automatic pilot, ignition, and starter switches are in the off position. Mixture control should be at idle cutoff. Throttle is set for 1,200 RPM. Check to be sure the landing gear control is locked in the down position. Then, if the engine has been idle for an hour or more, the prop is pulled through 3 or 4 revs to clear the combustion chamber. Cowl flaps are set to full open position.
Fuel selector valve on fuselage.
Propeller switches on and automatic. Prop control down for full increase. Carburetor air direct. Primer breaker on. And fuel gauge on. Battery on. Generator on. Starter breaker switch on. Ignition switch both. The electric inertia starter is put on and held in operation for about 15 or 20 seconds. Fuel pressure of 6 to 7 pounds is obtained by means of the auxiliary electric fuel pump. And the electric primer pump switch is held on from 1 to 3 seconds, depending on outside temperature. Then the mixture control is set at full rich. When the all clear signal has been given, the meshing switch is held on until the engine starts. If the engine is cold, it may be necessary to use the primer a few times to keep the engine operating. Now get this, it's important. Do not touch the throttle during the starting procedure. Leave it set at 1200 RPM until the engine is running smoothly. If the engine is over-primed, move throttle to full open, mixture control to idle cutoff, and the ignition switch off. Then by hand, rotate the prop 3 or 4 revs and repeat the starting procedure.
When the engine is firing smoothly, allow it to warm up at 1200 RPM with prop set in low pitch until the oil inlet temperature reaches 55 degrees centigrade and cylinder head temperature at least 130 degrees centigrade.
Engine oil pressure should reach 40 pounds within 30 seconds after starting. If required pressure fails to develop, stop the engine immediately and investigate.
The wings are spread hydraulically by turning the control handle counterclockwise and holding it. This is the first U.S. Navy dive bomber equipped with hydraulic folding wings. Depending upon the wind, these wings can unfold in 30 seconds because of larger hydraulic cylinders. When the wings are fully extended, the control handle is pushed full forward to lock the wings in place. When they are safely locked, the flag indicators on the wings will have receded until they are flush with the surface. Slats are provided on the leading edge of the wings to smooth out the airflow over the ailerons at high angles of attack.
These slats open when the landing gear is extended. And close when the gear is retracted and have no independent control. It is imperative that the pilot's shoulder harness be secured and adjusted as soon as he mans the airplane. And it must remain fastened at all times, especially when making a carrier landing, to help prevent head or face injuries in case of a barrier crash. The pilot's seat may be raised or lowered as necessary to give proper vision through the reflector sight above the instrument panel. Adjustments are provided on the rudder and brake pedals to suit the pilot's size and give him full positive control. Rudder pedals are adjusted by kicking out the ratchet release on the inboard side and moving the pedals to the desired position. Be sure that each pedal is ratcheted backward or forward the same number of notches. We should also check to make sure that hydraulic valves number 1 and number 2 are fully open and that both number 3 valves are fully closed. The hydraulic system pressure gauge should read approximately 1,000 pounds. When the engine is thoroughly warmed up, the throttle is advanced until the manifold pressure is 30 inches, giving less than 2,000 RPM. Then check your magnetos by moving the switch so as to operate the engine, first on one mag and then on the other. Hold the switch momentarily at both as you move it to check each mag individually. Normal drop on one mag is 75 to 100 RPM. More than this will indicate bad magnetos or spark plugs and should be investigated. Check the ammeter to be sure the generator is charging, and don't leave the line unless it is. Now check the 2-speed supercharger at an engine speed of 1700 RPM and not more than 25 inches manifold pressure. Move the supercharger control lever quickly to high and wait for increased manifold pressure to stabilize. Then return the control lever to low. If a sudden drop in manifold pressure occurs, the supercharger mechanism is operating properly. Check functioning of the constant speed propeller at a steady throttle setting of 1900 RPM. Move the prop switch to decrease and hold until the tach shows a drop of about 200 RPM. Then switch to increase and hold until original speed is regained. Finally, place the prop switch in the automatic position. Move the prop governor control up to give a decrease of about 200 RPM. Then return it to full down to give 1900 RPM. Before leaving the line, make one last check.
the operation of your flaps. First the landing and then the dive flaps. Remember, however, under no circumstances should you move the flap selector lever when the flaps are in any condition other than fully closed. As you taxi out to your takeoff runway, you'll notice what good visibility you have from the cockpit. Also notice that the rudder is effective for directional control, unless the plane is allowed to swing excessively. Use your brakes sparingly. They're power operated, which means that the amount of braking action obtained is determined by the length of time the brake pedal is depressed, not by the amount of pressure applied. On sharp turns, try to keep the inside wheel moving a little to avoid scrubbing off the tread. Turn the checkoff switch to bring the takeoff list into view and go through it carefully, item by item. Fuel selector valve, on fuselage. Auxiliary fuel pump, on. Mixture control, automatic rich. Carburetor air heat control, full cold. Supercharger control, locked in low. Prop control, automatic. And governor control set for low pitch. Cowl flaps, about 1/3 open. Rudder tab, 7 units right. Aileron tab, neutral. Elevator tab, normally neutral, but this will vary slightly with the loading of the plane. Tail wheel locked. Hood sections locked open. If the airplane is carrying a reasonably light load, the takeoff may be made with flaps up, as in this case. You'll need 44 1/2 inches of manifold pressure and 2,800 RPM for takeoff. When you're sure you have it, release the brakes and start your takeoff run. Prompt rudder action will correct any tendency of the plane to swerve during the early stages of the run. The tail will lift at a speed of approximately 55 knots, and at close to 80 knots, the airplane will fly herself off.
Hey, that doesn't seem like such a tough baby to fly.
That's for me. I'd like to try that myself.
Well, the only tricky detail is in the starting procedure. Some pilots say that they've had trouble in starting the engine, but that's only because they don't follow the right starting procedure. A priming should be done immediately prior to meshing the starter, and if necessary, while the engine's being turned over.
What about carrier takeoffs? How is she for that?
It's just as easy with the flaps down. Look,
This is a takeoff with flaps down 25 degrees for the full distance of the run. Although on a real carrier, 45 degrees is recommended. The same for landing and catapulting.
the flap selector lever is checked in the down position, and the flap control lever is held in the extended position until the flap angle indicator shows the desired number of degrees. Then the control lever is placed in neutral to hold the flaps in position. When flaps are used for takeoff, the elevator tab should be trimmed 1/2 a unit nose down for a light load and about 1 unit down for a heavy load. Your takeoff run will be somewhat shorter due to the increased lift of the flaps. Again, the tail will lift at about 55 knots, and the getaway speed will be close to 75 knots. As soon as you're safely airborne, retract the landing gear. To do this, the safety lever alongside the landing gear control is unlocked, and after depressing the locking button on top of the control, the lever is moved to the up position. The slats will close as the landing gear is retracted. When you have an altitude of at least 325 feet and an indicated airspeed of not less than 97 knots, bring up the flaps. You can overcome any tendency of the plane to mush as the flaps retract by bringing them up gradually, a step at a time, like this. As soon as possible after the takeoff, reduce manifold pressure to 35 inches and set prop control to give 2400 RPM, using vernier if necessary for close adjustment. As you climb away from the field, be sure your mixture control is in automatic rich and keep a close watch on cylinder head temperature. If the temperature goes above 230 degrees, open the cowl flaps for additional cooling. They create some buffeting at full open and have a high drag, so keep them not more than half open if possible. If head temperature continues to rise, reduce RPM or nose down to increase your airspeed. Never exceed 248 degrees centigrade under any condition. The best climbing speed varies from 140 knots indicated at sea level to 120 knots at 23,000 feet. For climbing at normal rated horsepower at sea level, you'll be turning 2,400 RPM with 42½ inches of manifold pressure. As you climb, this reading will decrease if the throttle is kept in the same position. And at an altitude of 9,500 feet, you will be able to get only 34 inches of mercury at full throttle. If you must continue climbing, retard the throttle slightly, then shift quickly from low to high supercharger. This will enable you to get 40 inches of manifold pressure at 2,400 RPM up to an altitude of about 14,000 feet. For cruising at 65% power, you can rev at 2,050 RPM and carry 28 inches of manifold pressure in low blower up to 9,000 feet, and 2,230 RPM with 26½ inches in high blower at service ceiling. Always shift the mixture control to automatic lean for maximum cruise operation, as well as for cruising at 60% of rated power on long scouting missions, where the prime consideration is fuel economy. This airplane is not as stable as most about the longitudinal axis and cannot be balanced to fly entirely hands-off. However, very little movement of the stick is required to keep her in the desired attitude. Now about the stall characteristics of the Helldiver. First, in the clean condition and with power off, the plane becomes left wing heavy, and at close to 80 knots, she stalls and rolls to the left. If recovery is made promptly, there is little tendency to spiral, dive, or spin. However, if the stall is permitted to go beyond its initial stage, as in this demonstration, the airplane will roll as much as 60 degrees to the left and go into a spiral dive. Recovery from this situation is slower, but otherwise entirely normal. In a power-off stall, with flaps down 30 degrees, as in this demonstration, the stalling speed is close to 75 knots. Again, the tendency to fall off to the left is characteristic, but recovery is prompt and normal, unless the stall is held beyond its initial stages. Then the roll will be more pronounced, followed by a spiral dive. With flaps down 45 degrees and power off, the stalling speed will be about 70 knots. And with full flaps, as seen here, the plane will stall at around 65 knots. However, she will squash very rapidly with full flaps, and high engine power will be required to keep altitude.
Porter, my boy, that plane looks good to me. I'll buy half a dozen.
Yeah, what about her speed? I mean, can she keep up with a fighter escort?
Speed? Brother, that's the fastest dive bomber this man's Navy has ever seen. Top speed of around 310 and cruises around 200. This Helldiver can travel in fast company, and you know what that means in terms of fighter protection. Here, watch this now. Dive bombing is the Helldiver's chief offensive mission, and the technique of handling this airplane in dives is extremely important. Before entering a dive, these preparations should be made. Hood locked open. Check your landing gear. If they're locked up, these lights will go on. Fuel selector valve on the tank with the most fuel. Mixture control, automatic rich.
Propeller, cruise RPM, plus or minus 100.
Throttle, set for manifold pressure of not more than 20 inches. Cowl flaps, closed. Bomb bay doors, open. Rudder tab, 0. To open the split diving flaps, the flap selector lever is moved to the up position. Then the flap control lever is moved from the closed to the extended position. This works hydraulically and the flap response is instantaneous. Indicated airspeed is less than 212 knots. Placing the flap control lever in neutral will hold the diving flaps where you want them. This airplane is steady in the dive and can be rolled easily with the ailerons to stay on the target. Terminal velocity will be about 300 knots at the end of a 10,000-foot dive. Recovery from the dive is made easily with a normal pullback on the stick. Avoid abrupt pull-outs, which impose undue strains on the airplane.
The Helldiver does all the usual acrobatic maneuvers. Its speed restrictions are according to current technical orders. Loops, such as this one, may be entered at a speed of 215 knots.
The slow roll, performed at a starting speed of 195 knots. The Immelman, executed at a starting speed of 243 knots. The Chandelle, entered at a speed of 205 knots. The Wing-Over, while flying at a speed of 173 knots. The vertical bank, performed at 170 knots. Before our performing Helldiver comes in for a normal landing, let's have a look at some of the emergency safeguards provided for the primary hydraulic system, which operates the landing gear, flaps, and brakes. If hydraulic system pressure falls off to a point insufficient for extending the landing gear,
Check flap control lever in neutral.
and landing gear control lever in up position. This may serve to restore pressure in the primary system, and when you have 800 to 1,000 pounds indicated, the landing gear, brakes, and flaps may be operated in the usual manner. If no pressure develops, close shutoff valve number 2. Leave flap control in neutral, and put landing gear control in down position. Then operate the hand hydraulic pump until the landing gear indicators on the wings show that the gear is down and locked in position. The hand pump also will provide pressure for lowering your flaps.
After you've landed, the brake accumulator will furnish pressure for 10 to 12 applications of the brakes, after which the hand pump must be used if further braking is desired.
If both these methods fail, open both number 3 hydraulic valves. This will permit the landing gear to extend by gravity in from 2 to 5 minutes. As the gear slowly extends, roll the plane smartly to help engage the locking pins. When the wing indicator flags come into view, you'll know that the gear is down and locked.
This will give you wheels to land on, but you can't lower your flaps. However, the brake accumulator will furnish braking power.
These optional emergency procedures inherent in the primary hydraulic system are vital to safe piloting of this airplane. Familiarize yourself with the operation of this hydraulic system and the various methods of controlling it. Then you'll be able to handle emergencies with confidence and certainty. As you come into the field for a normal landing, be careful to observe existing traffic regulations. When you've announced your presence and requested landing instructions, turn to your checkoff list and follow it, item by item. Tail wheel locked.
Fuel on best tank.
Supercharger low. Mixture control automatic rich. Propeller governor set for 2400 RPM. Propeller push button switch in automatic. Landing gear down and locked. Landing flaps down, but not until indicated airspeed is below 133 knots. Carburetor air direct. Sliding enclosures locked open. As you approach the runway, throttle back to about 90 knots. And you can set her down nicely on 3 points. The brakes are very powerful and have a decided effect, so use them smoothly during the run to keep control of the plane and slow it down. For a field carrier landing such as this, you'll use the normal landing checkoff list. But if you were coming into a real flat top, you'd also unstrap your parachute and put down the landing hook.
You should make your approach for this type of landing at about 85 knots, slowing down to around 75 knots as you're over the mat. Keep your eyes on the signal officer, not the airspeed indicator. This time you'll be coming in at almost a stalling attitude. Cut the throttle the instant you get the signal and land normally. After slowing to taxi speed, pick up your wing flaps, open the cowl flaps, and unlock the tail wheel.
Take it easy as you taxi back to the line. Give your engine a chance to cool by not revving more than 1200 RPM. When you've maneuvered into your parking spot on the apron and are ready to shut down the engine, idle at 600 to 800 RPM until the cylinder head temperature is at least 150 degrees centigrade. Then advance the throttle to get 1000 RPM and hold for half a minute to permit optimum scavenging of oil from the engine. Move the mixture control to idle cutoff position. And as soon as the prop stops turning, turn off the ignition switch. Close the fuel selector valve and cut all other operating switches before you leave the airplane.
I'm going out and have a closer look at that plane. Anybody coming?
Good idea.
Okay, come on. There are a couple of other features I want to show you, and since you've come this far, you might as well know the rest.
See this? It's a new strong horizontal stabilizer, specially designed for a 15,000-pound load. But it's been statically tested to 21,000 pounds. Nothing you'll ever have to do with this plane will make that tail flutter. It's really rugged.
Hey, fellas, look.
Yep, that's a metal upper surface. Gives a great deal more strength at high speeds. Engineers say it's a darn good thing.
How about this, Professor?
That's a handy little improvement intended to make your job less fatiguing. It's called the mid-span aileron balance tab. Here, let me show you what it does. Now watch what happens when I move the stick or a bank to the right.
When the control actuates the aileron, it also actuates this tab, which lowers into the slipstream and exerts additional lifting force on the aileron.
I get it. This helps pull the aileron up and makes less work for the pilot.
That's right. And it works in the same fashion when the stick is moved the other way. You'll notice the benefits of this after a long flight. Less fatigue. Take a look at the dive flap down there. When they're retracted, they're a smooth part of the wing surface. They don't affect the aerodynamic characteristics of the wing adversely. Yet when they're extended in a dive along with the landing flaps, they really slow the plane down, make for bombing accuracy and an easy pullout. Well, that's about all there is now. Of course, there's a lot more I could tell you, but you should take her up and find out for yourself.
Boy, I'm going to as soon as I can.
You fooled me. Well, I haven't been trying to sell you the plane, although I think it's a darn good plane myself. But I did want to show you that it's sound and dependable. It's got flight characteristics that make it equally effective as a scout, a dive bomber, or a torpedo plane. A combination like that makes it a good airplane to have in the fleet. Any guy who flies it properly has a mighty deadly weapon on his side.